And welcome back. This is, I think, episode 11, if I've got my count right. And I think today might be the day. I think we might get to draw a triangle. If you caught the last stream, you might remember, I think I might have said that to the start of that stream as well. And we got stuck. Well, after that stream ended, I spent another maybe 10 minutes just Googling, and I think I might have spotted the thing that I was missing in classic fashion. The second I turned everything off, I think it clicked. So what I did, I've pulled up the same stuff so I can sort of trace you back through my steps, is this dynamic rendering documentation compares the Vulkan 1.0 sort of render pass stuff that I've gone through before a couple times to the dynamic rendering stuff, which is new to me and where I was pretty sure my mistake was going to be. So I started reading this, and most of it looked familiar, except for this VK pipeline rendering create info. So we can go and have a look back in our code, and I did a check for, what was it called, VK pipeline. Oh my god, if only I could type pipeline. I forgot what it was called now. Pipeline rendering create info. And I discovered that we don't make one anywhere. So I went and had a look in the docs, and I found it over here, and it's got a bunch of stuff about color attachments in it, and we've not got one specified. Now this snip that I've taken out of the docs is just down here. And what it says is that if a pipeline is created without a render pass, i.e. we're using dynamic rendering, and the pnext chain of the graphics pipeline create info includes this struct, it specifies some stuff. If the structure is not specified and the pipeline does not include a render pass, view mask and color attachment count are 0. Which is interesting to me, because if you can remember the issue we're seeing, we can come in, let me, why is that not working? There we go. If we do an Odin build main debug, and we will run it in render doc so we can see what's happening, just to catch you up, because I don't expect most of you to have seen the last stream. We'll quickly pull our program up, and we will capture the first frame. You will notice there is no triangle. But we discovered that if I select a pixel in the middle, so we expect the triangle to appear in the middle of this screen, and we bring up the history, it starts out blank, it gets cleared to pink, and then as it goes through our draw, it goes from pink to pink. It looks like nothing happened. But if we expand this, we can see our shader does output a color, which tells us that everything is working fine up until the fragment shader output, and then something is going wrong. Right, this is our color attachment bit going wrong. So we can see on this thing up here that it's got information about color attachments, and this kind of lines up, right? That we're telling our graphics pipeline to output to no color attachment, so it has no idea what to do with the output, and so it just leaves it. And so our output image remains blank, and we don't see our triangle. So let's fix this to do, and hopefully we see a triangle. That's my best guess for now. I think if this doesn't work, we'll go back to the docs and do a bit more reading. But I'm feeling good about this one. So let me just bump the size slightly, because I'm looking at the stream and it's a little bit small. Can I drag that over a little bit as well? Is that a bit better? There we go. Right, so what is there to do? In here we're going to want to create a pnext, which we will call pipeline rendering create info. Are you actually a pointer to that? You're probably a pointer to that, aren't you? Where am I looking? Graphics, pipeline create info. Oh, it doesn't say. It's in pnext. It's pnext. It's a pointer. Yeah, so it's going to have to be a pointer like that. which will obviously be a error because we've not created it yet. So we'll come up here and we will say that pipeline rendering create info will be equal to a VK. Let me just remember what it's called. Pipeline rendering create info struct s type, as always, as this dumb, like, it just repeats the name of the type. So it's pipeline rendering create info. We only need the p next. We're gonna have to do another extension. View mask. I don't know what that is. View mask is a view mask used for rendering. Thank you. That is useful. I'm going to explicitly set it to 0. It will be 0 if I don't initialize it to a value, just because that's how Odin works. But if I put it in explicitly, I can't forget later. Color attachment count. We want 1. We're going to have to add a color attachment format. So let's format. I'm trying to remember now. Have I been stubborn elsewhere about doing a UK version color? I've got a mix. That's irritating. Okay, we can let this one be American looking. Color attachment format. And then we don't have a depth or stencil attachment. So I'm hoping I can just leave that blank and it won't matter. Because this one will matter. We need to go look up. Color attachment format is a pointer to an array of VK format values. Define the format of color attachments using this pipeline. Where format, I think we've got the swap chain image format saved somewhere. So we can say, in fact, can we go even simpler? Can we say you are renderer dot swap chain image format. Beautiful. So apart from view mask, I think that looks fine. Let's try running that. Still nothing. What do you say then? The validation error. Create graphics pipelines. Create info's pointer to color blend state is null, but create info's p next. Color attachment count is 1, and it has a format that we expect to be 8G8R8A8. The Vulkan spec states if render passes a null handle, the pipeline being created with fragment output interface state, and any element of the VK pipeline rendering create info p color attachment format is not VK format undefined, and the VK extension extended dynamic state 3 extension is not enabled. Sorry, hang on. Or any of the VK dynamic state logic or any of the VK dynamic state logic op enable extension VK dynamic state, VK dynamic state, VK dynamic state. Okay, there's a bunch of dynamic state you can set, which apparently we're not setting. Then p color blend state must be a valid pointer to one of these things. So let's go have a look for pipeline color blend state. Info, create info. Which isn't there. Nice. So you, where do you go? Are you on the create info somewhere? P create infos, P color blend state on create graphics pipelines. So create info. So you can't be that. So you need to be a color blend state create info. We'll come up here and we'll say color blend state create info is equal to a VK pipeline color blend state create info s type is equal to pipeline color blend state create info. Pnex we don't need unless we need it. Flags we should check. Logic op enable. I'm going to set to false and hope for now. And then attachment count, pointer to attachments. And blend constants. I don't know what any of those are. So attachment count is a number of VK pipeline color blend attachment state elements in attachments. Ignored if you're using dynamic state, which we are not, I don't think. Yeah, we're not using any of those. And then P attachments is a pointer to this thing. Okay, so we're going to have to make another thing. So let's have attachment count 1. And P attachments will have to be a pointer to, what we're going to call this, pipeline, color, blend, attachment, state. What is blend constants? It's a pointer to an array of 4 values used as RGBA components of the blend constant that are used in blending. I'm going to leave them blank and see what it does. And so we're going to have to then make another thing up here. Pipeline, color, blend, attachment state is defined as VK, pipeline, color, blend, attachment state, which will have an S-type. Oh, did it not have an S-type? S-type is pulling out of renderer. Maybe it doesn't have an S-type. We never check this flags. What does flags have in it? Rasterization, order attachment. Oh, I don't know what those mean. Leave it until something breaks, because I want to see this thing, which has a bunch of stuff on it. But I'm hoping we can just disable blend. So blend is about if I've got... How do you say this? I've got my thing that I'm drawing over the top of something else. I want it to be allowed to be transparent, and I want to tell it how it's going to show the underlying colour through it. You have to define these operations to tell it how to do that. I'm hoping, for now, we are going to have to sort this out later, because we are going to want to be able to do this. If you imagine where we're going with this, we're going to draw a triangle, we're going to expand on our drawing triangles to draw squares, then we're going to apply textures to those squares, or yes, just to quads, they don't necessarily have to be square. And that gives us the ability to draw very simple sprites. Those sprites will likely have potentially significant amount of transparency around them. And that's how we're going to draw non-square things, right? Is we'll draw a square, and then the actual image applied will have transparent edges around it. So we will have to come back and deal with this, but let's see if I just disable that. Do I care about any of the rest of these? So yeah, see all this blend factor and blend op we don't need at this point. What is color component flags? Bit mask of VK color component flag bits specifying which of the RGB and or A components are enabled for writing. As described for that thing. I mean, we want to write all of them. So do we just put them all in? Bits which can be set in that, determining whether the final colours are written to the frame buffer attachment are this. So if R is on, it specifies the R value is written to the colour attachment for the appropriate sample, otherwise the value in memory is unmodified. Colour write enable is not... Okay, yeah, so I think we just want to turn them all on, so we're going to say blending is disabled, but colour write mask is everything in here. So what we're saying is we aren't handling transparency. So our triangle needs to be just a solid block. I don't know what it would do. In fact, does it say what it does? It do if there is transparency? If blending is not enabled, the source fragment's colour for that attachment is passed through unmodified. So I guess maybe if you pass through something transparent, it just gets it just ignores the transparency and it just draws whatever colour the RGB says it should be. Okay. Doesn't matter. We'll deal with that in a bit. Colour write mask says we're going to write every value. We'll save that, do a check for errors, and we don't have any coming up. Clear U. We run it, and we have a triangle. Ladies and gents, we've done it. Should I be surprised it's upside down? In my head, we did this the other way up. But maybe I'm just being silly. So let's get that in there. So what do I want to commit? Triangle. Nice. What was I looking up? I was going to go and have a look in main.odin, just check our values we're passing in. So screen coordinates are given from -1 to 1 on both axes. So whatever size our window actually is, if we were to drag a corner around, it's always going to go from -1 to 1, -1 to 1. I think that's done from the top left corner. And so if we look at this, so -0.5, -0.5 will go to the left and then up. So you go from the middle, we're going to go to the left and up, and we have 100 says red, so that's as expected. Then we've got our, what does that one say? 0, 0.5 is here. That's got 0, 1, 0, so it's green, and that one is blue. Excellent. I am realising now, I think we defined front facing as clockwise winding, and that's looking pretty anti-clockwise. So we probably need to go back in here. If we put in our back face culling again, I think we're going to see it all vanish. Yes. And we can fix that by changing user to, say, counterclockwise. And there it is again. Excellent. I mean, we picked clockwise kind of arbitrarily. I don't know if there's a sort of de facto standard for what people do for this. So I think we just pick that and we're fine. It's just something we have to be consistent with as we go. Excellent. So let's get that back in. Let's say re-enable backface culling. Now I am slightly curious if we go and run that. What would be Odin build main debug. If we head back to render doc and we run it again, can we pick out the thing that was wrong? Right, like it took me a honestly painful amount of debugging to clock what we were missing, and for all the tools in the world, nothing seems to actually catch this. So we have a look at our pipeline state. We now have a frame buffer. Did we have a frame buffer before? I honestly can't remember. Maybe I have to go back and watch my own stream to try and work out what the difference we were seeing is. I think we might have just not had a frame buffer. So what's this say here? Frame buffer dynamic, render pass dynamic, target blends is enabled is false. What's this say? Col. And, okay, so color source destination op, alpha source destination op, right mask is these things. Cool. Very cool. And the rest of this all looks the same, right? So this is what we saw before. We can see our mesh coming in, and we can view our texture. We can interrogate individual pixels, so we can see this pixel down here and how we got to it. And this is where the things are different is, well, this is a thing that is different. Because we now have the color attachment set up properly, we can see our shader output is getting written to the image. They're not exactly the same. Like, they're very similar, but they're not exactly the same. That's interesting. I wonder what that's about. Is that true more generally if I pick some other points? So U 444 to 445, 264 to 262. Yeah, they all seem to be accurate to like 1 decimal or 2 decimal places, which is interesting. What if I pick something right in the corner so it's right near, like, the red? So right up. So this should be near pure red. 983, 982. Yeah, no, they're not quite the same, are they? That's interesting. Okay. So, interesting, but like probably not human detectably different. Probably implementation dependent in the driver, I guess. But yeah, that's it. We have a triangle drawn. So, I think there is something I would be interested to see as well. So if we close you and don't save that. If I go back to, oh, where would it be? Where we've done this search for that? No. Can we search? Is that not a regex thing? For .r, this one. So what do we get if we take one of these out? So let's say no green, I guess. So we delete this. And we Odin run main. I think it just means our green corner won't be there. So it'll look like it fades into the background. Or it goes black. No, that's it. It goes black. And it goes black because we don't have blending enabled. Does that sound right? So if I go build that. And we render dock again. And we launched that one. Capture the first frame. We should see our shader says this should come out as green, and then our program refused to write the green across. Yeah. So what we got was very near black. So if I scroll in all the way, so we can see right at the tippy tip, where it's very, very black. It should have been very green, and what we got out was very black. Cool. And you see the red and blue values go through basically unchanged. Neat. Neat, neat, neat. And again, oh, actually no. So an alpha of 1 means opaque. So we are just writing an opaque thing, and we're just zeroing out the green because the green wasn't there. Cool. Well, I feel like I understand that slightly better now, so that's good. I do want to put that back though, so let's get restore you back into place. I'll push that up real quick. Sweet. Now, is it worth a bit of a look to check? I did a lot of fanning about with my draw frame while I was trying to get things working. I think it might be worth taking a minute now to just walk through it again and check if we actually do need all the things that I thought we need. So, what do we have here? So this fence to wait for the previous frame to be done before we start, we definitely need. What do? We get the next swap train image. We definitely need. The fact I'm doing this with a fence instead of a semaphore, I think is still a bit of an open question in my head. But that should work. Well, sorry. Oh. We can revisit that if and when it causes us trouble. I like clearing to this gross pink because I think it really stands out, so we're going to keep that. This color attachment info, which is pointing at the right image view. It has an image layout of this. What happens if I delete one of these image layouts? Right, so we've got an image layout transition to put it into color attachment right. So if I understand right, if I come in here and I do this, and I say comment block, and we Odin run you, it does work, but with a load of validation errors. What are your errors? Present info, swap chains, images passed to present must be in that layout. Must be in present source. But the image is in layout color attachment optimal. Did I blank out the wrong one? I did. Okay, so that's our transition to presentable. Where's our transition to... yeah, that one. Are you needed? Can I remember the commands? So let's say comment block. Get that one out there. Kill that. Clear. Run it again. So it does draw the triangle, but angrily. So what do you say? P submits, P command buffers, command buffer, VK command buffer, expects VK image. What's all this? To be in the layout, color attachment optimal, instead it's in that. So these are definitely doing what we think they're doing, right? If I comment either out, things start breaking. So that's good. So we definitely need both of those. That's then happy. So we have a image transition. Where did these even land? Because I fannied with these a lot. So the first one goes from undefined to color attachment optimal. Where does it do it? Do you have to say somewhere at color attachment output? And then down here we have a memory barrier transition to presentable that we do at the bottom of the pipe. So at the end of the graphics pipeline, we make it presentable. This is the rendering info stuff. Is that what we just added? Rendering info, render area. That's not what we just added. So that goes into command begin rendering, begin our dynamic rendering run. So we're now allowed to do drawing commands. We bind our pipeline to the graphics bind point. So we now have a pipeline that it knows it's going to be able to submit drawing commands to. We bind our vertex buffers. This is probably actually where we come to next, is we're going to add a index buffer. We might give that a quick go. I don't think that should be hard to do. Yeah, so let me see that in here. So to do next, is it just called draw index, if I remember right? And I think it should work basically exactly the same, but we'll need to pass in a index buffer as well. Draw indexed. Oh, what's all that? Where's just draw indexed? What's all this indirect about? That's what I want, is command draw indexed. Drawing commands. Let me snip down a little bit. I swear this had like a little thing where it was like there are two forms of draw command. Draw indexed. Okay. Stream buffer offset. Am I just being stupid? Am I just like whizzed past it or something? Draw indexed indirect. Will that link back to it? Draw indexed indirect. I just nip up here. Is it up here? My God. Just keep going. Draw indirect count. Draw indirect count. Indirect command. It's gonna be something silly, like it's actually called indirect draw or something. No, this isn't gonna be indexed. It's gonna be indirect. Okay, screw this. We'll find it in a bit, but that's one of the things we want to do next. Actually, though, before we do that, I think I have to be slightly mindful. So, I've not got a lot of time today because I've got to be up early for work tomorrow. So yeah, let's resist the urge to go and add an index buffer. But we can certainly go and add another triangle. Right, so here we have triangle 1. Let's add triangle 2, and I think I've not hard-coded any lengths in. I think all of the things like number of data points it's expecting and the size of the buffers is hopefully all done. So if I just add things to this, it should all just work. We'll have to do a bit of tweaking here though. So let's make this, if we can get this right, our top left. And we'll make this our bottom right. So we're going to make the quad we draw in screen space go from minus 0.5 to plus 0.5 in both directions, which means our top left corner can start at minus 0.5, minus 0.5. We're going to go counterclockwise, so we now need to come down. So this will actually now be at 0.5 minus 0.5. And then it needs to go up and across to 0.5 minus 0.5. No, I've done that wrong, haven't I? That's not gone down. So you're going to go to that one. So minus 0.5 on the X means left, and plus 0.5 means... Oh. What does it mean? It means down. See, I've gone down, and then we're going to go up and right. So plus 0.5 means right, and minus 0.5 means up. And we're going to keep that RGB. And then over here, let's do just a quick bit like that. I'm going to put these comments in the end, stop it formatting it annoyingly as well. So now this one, if we think we've got one triangle in the top right, they're going to share 2 points. We're going counterclockwise. So if I take the top right, that can then come down and left, and then right to our new point. So our top right matches this one, because that point's on both. We can then go to the left and down, and that point is on both. And we can then go to the right, and down, which is our new point. And this one I will make various shades of grey, I guess. You could be 0.7, 0.7, 0.7, and 0.3, 0.3, 0.3. Let's go with that. So hopefully what we should see now is a square that has our RGB in the top left and like a grey gradient essentially in the bottom right. There we go. Easy. That feels like it's a nice, I guess, little sense check that all of our buffer creation stuff is being done sensibly. So let's commit that 2 triangles for a quad. I think one thing this shows then is actually maybe a good primer for what we're going to do probably in the next stream. Because like I say, I need to be up early tomorrow, so I think this is going to be a nice short stream. But like I said, I felt like I was close to getting a thing drawn, so that's I'm chuffed we actually got there. As you can see, to draw this quad, we've actually defined 6 vertices. In this case, it's worked well for us that we could define them to be very sharp and different like colours, But you can imagine probably in most cases what you'd want, in fact we could do this, is these two corners that are common to the pair, probably actually, if I was drawing this to be like a reasonable quad, they probably match, right? So what we have probably looks more like this over here. And the fact that we're having to repeat ourselves is not nice. And we get around this with our index buffer. I've just seen a whole bunch of comments. So that's exciting. Hi, everyone. Hola. You've picked a good day to randomly turn up. Hey, yeah. After a painful slog, we've finally drawn something. So the whole experience, I guess, is in all the videos. If you want to go and watch me suffer through, what is it, 10 episodes now of setting up a Vulkan pipeline. We've done it all from scratch, mostly from memory with the spec. We now have two triangles. We now have a quad. So beautiful progress. I feel slightly bad because I was just getting ready to wrap up. I've not got a lot of time to hang around today. So I was whoa, two triangles. I'm hoping we'll get more impressive. Do you want to see? So this isn't the first little bit of Vulkan stuff I've done. I guess there is a seam in this quad. This is true. I've followed in the past through the Vulkan tutorial, which goes through the kind of 1.0 like non-dynamic rendering stuff. I've gone through that a couple times, and the second time I went through, I extended it slightly. So let's detach out of that and go find this. So I used Bracky, big YouTuber, has a set of like free assets available that are made for sort of like making your first platformer in Godot. So of course we didn't do that. We wrote our own Vulkan rendering pipeline and put together a little game. At its core, this is doing exactly the same thing that other one was doing, right? It's just drawing quads and applying textures. That sound might be really grating. I'm not worried about the sound on the stream because nothing else is making sound, but I just won't jump again. But yeah, this is basically what we're building towards. So, like I say, we've just broken that first painful Vulkan hurdle. I don't know if any or many of you have written any Vulkan code, you know that it's a slog to get to that first triangle. Hopefully, it's all downhill from here in a good way. Difficult turn of phrase. But yeah, we're going to add an index buffer. We're going to go through and it's not. Yeah, no, it's. I think it's more fun from here, if nothing else. Right? I think there is something soul destroying about that early Vulkan work where you're just piling in more and more things. You half understand it. If any one of them's wrong, the whole thing doesn't work. In fact, if you go back and watch the start of this, the last stream, I said quite confidently last stream that we were going to get the triangle drawn. And it didn't happen for us. And it got to a point where I was just like, I don't know what I'm doing wrong. I'm going to have to step away. And then on reflecting, can I find where it was? It was one of those where there's a pnext that I hadn't set that it didn't trigger any validation errors, so there was nothing flagging very obviously. I was kind of relying on the validation errors to catch things I was missing in the dynamic rendering stuff. Can I remember where it was? Somewhere in here. It's not in acquiring the thing. It will be, I think it's on the create pipeline. In fact, there's not a lot of pnext being set. Is it this one? It's not that one. Can I find create graphics pipeline? Oh, I'm flailing. It's one of these. Basically, one of these had to be set as a pnext. And missing that meant that everything worked, right? So I was pulling it up in RenderDoc. I could see my vertex shader was working. I could see my it's weird to call it a mesh. I don't know what you call it. But in the mesh viewer, you could see my triangle was coming in and all the data was there. And most painfully, I could see from the like texture output viewer that in the history of a pixel in the middle that it had been colored green. Yeah. Well, I'm not sure how to say your name. Is it Arceus? Arusius? He's bang on. That's the mistake I made. Yeah. So I'd forgot to set that to P next. I might have to go back and look in the old like stream videos, because I'm sure it'll be a place where I was like, I don't know what that is. I'll make it nil. The validation layers will catch me if I've got it wrong. And they did not. So I flailed and I gave up for the day because I was just at wit's end. But hey, it worked out in the end. It's the fun of Vulkan rendering, right? I also quite like somewhere up here. So obviously, as I'm going through, I do the sensible, set my cull mode to backface, and I actually had it set to clockwise initially, because when I'd written this here out, imagine this had the one triangle in it, I was reasoning it through, and I, in my head, was drawing the triangle and going, okay, this is clockwise, therefore I need to be clockwise, forgetting that obviously in screen space, -1 is up and +1 is down, so my thing was all backwards, so clockwise was anti-clockwise. I was kind of aware of that as like a pitfall though, so I was all over that one. But yeah, that was a painful one. Actually, just because of... Let me just check the time. Yeah, I've got 10 minutes. Do you want to see in that Bracky platformer the painful thing that got me in there? Oh, where would it be? It might even just be in the shaders is the easiest place to point it out. What would it be in? I guess it's in the fragment shader. Would it be in this one? This line was the last case I had of something similarly painful. So can I remember what I was actually doing here? I added on my vertex data an index to say which image I wanted to be sampling. With my thinking being that I have a set of texture samplers and they're still uniform, so I'm fine to be passing them in as uniform because they're the same across all of my invocations. And then my vertex will tell it which of those different samplers to use, so I can apply a different sprite essentially to either to different entities or to the same entity as it goes through its animation cycle. And it more or less worked, except that I was getting... I don't know if I just... See, I'm not good enough at GLSL to know if I just remove this line if the entire thing will keep working. So I've had to enable extension in other places as well. And like I said, I've not got a huge amount of time. But what it ended up doing is it all rendered, it all worked like it was meant to, but random pixels would be the cleared color. And that took me days to get to the bottom of. The issue being that I guess when it says that it's a uniform across a batch of what you call it, like calculations, I guess what they really mean is that like when it's grabbing that value, it's uniform. So the fact that I'm indexing into it and grabbing different values on different parts of the calculation across a batch of submitted work meant that you were getting undefined behavior. And that undefined behavior manifested, in this case, on my particular graphics card with my particular driver as seemingly random cleared pixels. Like I say, it looked random. I think the thing that I cottoned on in the end that it's not random is I'm using a tiling window manager, so it's easy to flip kind of consistently between different sized windows that are all of the same size each time. And as you did that, if it was going back to the same screen dimensions, it got you the same random set of cleared pixels, which was just infuriating because it clearly meant there was a pattern. It wasn't like it was something actually random, like it was like some freed memory or something that was then getting messed with. So on different like draw frames, it'd be different. Oh, so this, I think this may just be the Vulkan programming experience. Is you find a corner you didn't really understand, you trip over it 6 hours later, and then you spend days slowly unpicking. But no one said learning was easy, and I've not been scared off yet, so I'm clearly having fun. Yes, Arceus is awesome window manager. It's not particularly pimped out. I think I set all my backgrounds just blue, because I did have a background at some point. I think fanning around with trying to get it to resize as I went between different monitors and things just seemed boring. I know you can do a lot of stuff with like adding stuff down in your widget bar. I think maybe in the future, maybe I'll do a stream where like, maybe if I can find people who are better at these things than I am. I'm bad at, I guess, writing. My configs are all a mess. I've switched recently to Cocoon in part because my NeoVim config was a mess, and sitting to rewrite it again didn't sound like fun. So I've tried a different thing out. So yeah, no, it's. Although that said, I have landed, I think, on a set of like key bindings that work quite nicely for me. So I found I have it set up so I can drop into a desktop environment as well. I think I'm trying to think if I ever use it. I use it sometimes, right? If I'm just like chilling and watching movies, it's nice to be able to just drag around windows, or if I'm using the laptop showing my girlfriend something, it's easier if she can also use the computer without having to memorize all of these weird key bindings. But yeah, no, I'm very happy with Awesome. Although I think Awesome's X11 only, right? I can't use it on Wayland. So at some point, I might have to try something else. Which again, might be fun. Like I said, I think I've had fun moving to Cocoon. I don't know, I'm feeling like experimenting a little bit. So, yeah, maybe that's a future stream. As nice as it is to have had everyone show up, I'm kind of at the end of what I was going to do. I've got to get up early in the morning for work, so I'm going to have to go. But it's been very nice chatting with you. I hope you've enjoyed the little bit of Sin. I say you picked a nice one to turn up to. So yeah, maybe I'll see some of you again later. But no. See you all later.